All right, welcome everyone to the CID's Internet of Things workshop. Thanks so much for being here. We can jump right in. So first of all, thumbs up if you're able to see my screen okay with the slide. Sweet. So today's workshop is about the Internet of Things. And what this term means is that more informally, everything around us is more and more becoming connected with each other or to the internet. All our devices talk to each other in some form, or they're like call home in some form. And so whether it's like your toaster, your fridge, your TV, even your Tesla, they all are like hooked up to some sort of network. And from there, they're able to like pull in more information, send information, and get updates, and really have like all of the benefits of always being connected and always being online. Now, before we sort of move in and explore how to use the Internet of Things to our own advantage, there is like a slight disclaimer that the Internet of Things does not come without its own disadvantages. So sometimes adding network capabilities to your devices might be overcomplicating something that like doesn't need to be complicated. It's like your toaster just needs to toast. So maybe it's not a good idea if it's connected to the internet all the time. And so there are lots of like, this is an ongoing conversation and discussion about the ethics of Internet of Things, which we won't go into here, but it's always worth remembering and keeping in mind, like how do each of the technologies you use impact the people around you and also the product itself. So that's just something to keep in mind as we go along. So that was a short introduction to what the Internet of Things is. And I'm going to comment on this cover photo that we have here on the slide. Throughout this presentation, I'll be referring to the smart lamp that we put together at the CEID. And I'll go into the design of this lamp and how it works, but essentially it's connected to the internet. So it can do all of the things that a network smart lamp can do. So you can talk to it with your voice, you can find a control panel on the internet to talk to it, you can press some buttons on the interface and it will light up for you. So I'll demonstrate that now. And what we'll do is work towards building up towards creating our very own smart lamp. So I'll start with changing my camera to this lamp here. And I'll explain the design of this lamp momentarily, but essentially it's an Arduino, which is this microcontroller that's connected to the internet, and it controls this ring of LEDs here. And so there are lots of ways that I can control this. I can control this with Siri or maybe through some other program. And so I'll show the Siri aspect first. I've got this shortcut here, which lets me control it. So turn on lamp. And I can also ask Siri to turn it on for me. So, hey Siri, turn on lamp. Awesome. So the demo gods have been kind to me. I will now switch back to the normal camera. And so what we're going to do is through the course of this workshop, figure out how to build this for ourselves and learn about all these networking concepts along the way. Sound good? Cool. At any point, feel free to sort of unmute or raise your hand and ask a question. Antonio will also be monitoring the chat from time to time, and so will I. So let me know whenever you have a question. All right, let's move on. So one of the questions we get asked at the CID a lot by students working on their projects is, I have this Arduino or this Raspberry Pi that connects with all of these other things. So it's connected to some LEDs like the smart lamp that I just showed you, maybe some motors like in a toy car, or some other fancy piece of electronics. And they can communicate with it over serial just fine. By serial, I mean, if you connect a cable from the Arduino to your computer, you can program the Arduino just fine through your computer. But they often want to like move a step beyond that. So for whatever reason, like the Arduino might be in a remote location, or it might be like in a place that's not easily accessible. And so the question is, how can we take like this web app that we're making or use our phone and communicate with the Arduino wirelessly in some way? And so this wireless communication aspect is a big question mark, and there are lots of ways to go about doing this. So before I go on into how that wireless communication works, I want to sort of give an example of what this setup might be like. So this Arduino talking to all of this other stuff like LEDs, motors, and things like that. And so last week, Antonio did a great job of going through the fundamentals of electronics with Tinkercad, which is this really nice online platform to let you simulate circuits without having to purchase all of this equipment. And all of our previous workshops can be found on the Yale CEID YouTube channel. So we have a bunch of workshops for how to build your own apps and how to create your own electronics. So definitely check that out. But for now, what I want us to do is I'll put this link in the chat and we can take a look at how the hardware side of things is done first. And then we'll move on to the software and the connection stuff. So I put this link in the chat. And if you don't have a Tinkercad account, it might prompt you for one, in which case that's totally fine. And Antonio also put in a link to the original Tinkercad workshop as well. So definitely check that out when you have time. So everything that's inside this box, this smart lamp box, consists of this setup essentially, which is this Arduino that's connected in some form to these NeoPixels, and that's it. So all of this setup, like this 9-volt battery, this like voltage regulator, this NeoPixel stuff, that's entirely context dependent. Your project might be doing something different, like you might have some servos out there, you might be like driving something else instead of LED lights. So that's entirely dependent on what you're building. But we can sort of, if you click Tinker this, we can sort of inspect how it works. And if you click code here, you sort of see the code is fairly straightforward. So there's some sort of external module that the Arduino is connected to. It uses some external library called Adafruit NeoPixel to drive those LEDs. There are a bunch of variables which correspond to the color of each LED on this NeoPixel ring. And all the code is doing is sort of going through in a loop and setting those LEDs to a different color. And this is not exactly the code that I have on this actual hardware, but it's quite close. So if you're able to go on this website and click Start Simulation, you sort of see what it's doing. And this is a great way to prototype this interaction for yourself before actually going out and getting hardware to do it. So thumbs up if you've been able to go to the tinkercad.com website and have been able to check this out. So this was my starting point. I rigged this up in Tinkercad and saw that everything was working. Then I went out to Adafruit and got all these electronics that I needed. And then I started on the software end of things, which is namely, I've got all this stuff working on the Arduino, but now suppose I want to connect with my phone to the NeoPixel. How would I go about doing that wirelessly? Does anyone else say page missing, or is it just me? Let's see. Let me share it maybe some other way.
You might have to have a Tinkercad account if you don't already have one.
Okay.
It's free.
I sent another link over. Maybe that helps, but if not, then I apologize. We can look at it through here. Awesome. That link seems to work. Awesome. Perfect. Great. I'll also just update it here when I send the slides out, so it's available for everyone. Great. So the point of that was just to show that Tinkercad exists. It's a platform. Antonio's covered it in the past, and it's a great way to sort of prototype stuff without having access to hardware to begin with. And it also gives you a visual into how this white box, this black box is working. So let's move on. So now we come back to this question mark, like how can we communicate from your phone to the Arduino? And there are lots and lots of ways to do this. And in fact, there's so many ways that it kind of becomes overwhelming. And so I've sort of gone ahead and evaluated a few of these already and came to my own conclusions about what might be the most suitable for a beginner workshop. But after you sort of go through all of these protocols or like alternatives, you might have your own opinions. So I've tried to categorize them as best as I can. So in general, you can connect with your phone or some website or your computer to an Arduino, either locally or through the internet. So if you connect locally, then Bluetooth is a really common option. Like if you have a Bluetooth radio on your phone, for instance, then I'm sure some of you have used like a smart speaker before in the past, where you can just like pair with it. And Antonio just held up a module, which is like an Arduino, but has a Bluetooth module built in. So if you have an Arduino that has any sort of Bluetooth capability built in, or even if it doesn't, you can buy an extra shield that can go along with that, and that'll give the Arduino Bluetooth capabilities. Then you can just pair with it super easily with your phone. Alternatively, you might use something like Wi-Fi. And so if you have Wi-Fi but no internet connectivity, then we just refer to it as like a local area network. It's like within your without going too much into the technical weeds, it's like you're just not connected to the internet. So you couldn't visit google.com on either of your devices. What you instead have is some local network, and you're just connecting to the Arduino through there. And so because this is just like basically like the internet, but without the internet part where you can't access things outside of your local area network, you can use all of these same protocols that you would be able to use with the internet. So you can use things like HTTP, if you've ever heard of that. WebSockets is another one, and MQTT is another one. So all of these things, regardless of whether or not you have an internet connection, are available to you as well. So for instance, the Arduino that Antonio just held up, it can create something called a local web server, and your phone can just connect to that too. So it's kind of like the Arduino comes up with its own Wi-Fi network. So just like your Wi-Fi network at home, the Arduino will make its own Wi-Fi network, maybe called Arduino 123, and then your phone can connect to that. Now, both the Arduino and the phone are on the same Wi-Fi network, and they can talk to each other. However, if you use the internet, then you're not sort of constrained to your home network anymore. Then your Arduino could be in a remote rainforest doing some sort of humidity pressure sensing, and your phone could be with you here in New Haven, Connecticut, and you could still talk to one another over the internet, provided that both ends of the connection have internet access. So the Arduino in this remote area must have internet access, and your phone in New Haven, Connecticut must have internet access. And then you can leverage the full power of the internet to sort of talk to each other wherever you are in the world. So this sort of opens you up to more possibilities than you would just by having something which is local. So you can use like cloud services that are provided by big companies. Arduino provides its own service. Particle Photon is like a pretty common service. So all of these things are available to you to sort of talk to all your devices remotely. And you can also use these three same local protocols, HTTP, WebSockets, and MQTT, and I'll explain what each of those mean. You could use them as well to communicate with your device. So if some of that is not clear, the takeaway from this slide is that there are lots and lots of ways to communicate with your devices, and there's no one-size-fits-all solution. So you have to go and sort of evaluate each thing for your particular use case. So for instance, if you have this, like, suppose you were making a toy, for instance, that you want to connect to, and the toy is only ever going to be like on your desk, then it wouldn't make sense to connect to it over the internet. You might want to do something which is more local. Alternatively, if you have something that's doing some sort of monitoring in a faraway location, then an internet-enabled access might make more sense. Any questions about this slide?
Did you say that the local is usually faster than internet connection?
Yeah. Yeah, I would say so. Just like your physical proximity makes a big difference. But if it comes down to maybe, it might come down to the order of like milliseconds or seconds. So depending on your use case, it may not make that much of a difference. Like for me, turning on this lamp from the other side of the world might take around the same time, give or take, than me turning it on locally. But if you want something that's streaming real-time data extremely fast, then maybe local is a better option. Any other questions? Great. So I won't be covering HTTP or WebSockets here. Instead, what I'll be covering is something which I found to be pretty beginner friendly, and it's called MQTT. MQTT stands for Message Queuing Telemetry Transport. You can just forget about that or ignore it. You can just call it MQTT. And what it is just like HTTP. So whenever you visit a website on the internet, you always put HTTP google.com, right? Or you put HTTPS. Yeah, so there are lots of, this is like the protocol for the web, hypertext something transport protocol. And so what that's transferring is just web pages. And so what MQTT is transferring is just messages over the internet. And so it's quite similar to HTTP. And with both HTTP and MQTT, you might want to set up a server, like your own sort of middleman, or you can just use one of the many free MQTT brokers out there. And I'll sort of go into what that means a bit more. So the takeaway from this slide is it's very easy to get started with MQTT. And to demonstrate how MQTT works, we're going to have a little bit of fun and create our own chat room. And so this is going to be a way for all of us to interact and kind of have something like internet message, like Facebook Messenger or Slack or something like that, just for this workshop, just amongst us. So I'm going to do is take this link. I'm going to put this in the chat. And I'm going to open it up here as well. All right. So I'm going to wait until all of you have it open, and we're going to then play along. So just thumbs up when you have it open. Sweet. So there are lots of different MQTT brokers out there. You can think of them as servers. And what they're responsible for is sort of carrying your data across the internet for you. And we're not going to use this broker. We're going to use something else. We're going to use test.mosquito.org. And it's another popular MQTT broker. I'm going to put this in the chat. For the port, we're not going to use 8000. We're going to use 8081. Put that in the chat too. For your client ID, you can use anything. If it's whatever it's giving to you, that's fine. And everything else you can ignore. So once you have these three pieces of information, the host and the port, test.mosquito.org and the port 8081, and any random client ID, you could put in your own name as well if you wanted. Just go ahead and click connect. And it should say connected. So I'll wait for everyone to reach that point. Just give me a thumbs up.
Mine says socket error undefined.
Just try refreshing the page in that case. Sweet. I'll wait for a couple more thumbs up before I move on. Anyone having trouble so far?
Still getting a socket error.
Yeah.
Try to refresh maybe,
Error.
or try putting something else for your client ID, like just your name.
We don't have to be on like VPN, do we?
No. For
Make
the
sure you got
purposes of this step, what's up?
mosquito with 2 T's. I messed that up.
Oh yeah, mosquito with 2 T's. You can copy it exactly as, and the port 8081. So this is just for demonstration purposes. So as long as Antonio is on there, we can have this demonstration. So once you have your connection connected, you'll notice that there are two tabs. There's a publish and a subscribe. Actually, once Antonio and I show this, we'll just refresh the page. So we go back to the broker, the original details, and then we can all still have a go at playing along with this together. So for now, I'm just going to assume Antonio is connected to test.mosquito. And they're publish and subscribe. So what MQTT is based on is you have topics you can publish to, and you have people who can listen or subscribe to those topics. And so someone can send information or publish information to a topic, and everyone who's listening for that subscription will be able to subscribe or get that information. And so one example topic that we could try out is, for instance, CEID. Okay. And for the message, I'll do anything like, hello, it's Sarim. And I'll hit publish. And so nothing's going to happen. But that's because I'm not subscribed to anything. So I need to add in a new topic subscription. And I'll subscribe to that same topic. Now that I'm subscribed, I can hit publish and I'll get that message. So Antonio, if you can publish to the topic CID with hello, it's Antonio, I should be able to get that message. Okay.
I just sent it. Do you have to refresh?
You just want to use the topic CID, hello,
CID,
whatever, and the
then
connection should be the
CID.
same. Test all mosquito.
We should make sure test. Oh, mine has test dot. Sorry, mine defaulted to a random one.
Okay.
Test dot mosquito dot what?
.org and 8081.
8081. Sorry. Okay, now it's getting me socket errors undefined, unfortunately.
Okay. Well, maybe we can just use the what's deep by default broker.mqtt dashboard. Now everyone can play along. I just kind of wanted to show testallmosquito.org so everyone could play with the lamp, but that's totally chill too. So don't edit anything here, just connect and let's just go to the CID topic and subscribe to it as well. And just write hello, it's Sarim or hello, it's X. Great, I got my first hello. Who was that? Whoa, maybe you all can identify yourselves. Antonio, perfect. So, great. So in this case, it was just great, it's Anusha, Jack, awesome. Everyone's coming through. So what everyone's doing is using this broker, which in this case is broker.mqtt dashboard. Mosquito totally flipped out on us, so that's their fault. And we're using this broker to sort of send information over the internet to us. And so there are people who are publishing those, and they do it through here, and there are people who are subscribing. And so your Arduino can be both a publisher, it can send information along this MQTT broker, and it can also be a subscriber. So it can pick information from a topic too. So in this case with the lamp, I can send information about like what color I want each pixel to be, or if I want to turn it on and off, and it'll make the lamp light up. So that's the general gist. So for instance, if I go back here, I know that this isn't working for some of you, but I use this broker. I'm just gonna connect to here. So I'm connected here. And what I'm gonna do is switch out my camera to the lamp. All right, so you should be able to see the lamp now. And so what I'm doing here is on the topic CID workshop, which is what the Arduino is listening to, I'm sending in a random message. Now I can just put in anything and it'll do a default color, right? So you can imagine that the Arduino is subscribed to this topic CID workshop and it listens for messages that I'm sending. And so it got some random message and it used that to turn on. So it's not that different from us just sort of playing in this, playing with this broker together. Someone clicked that just now. So I'm assuming whoever managed to get connected to test or mosquito was able to send that message too. But yeah, that's the general gist. And it's pretty simple. They're publishers and they're subscribers. You can make your Arduino either a publisher of data or a subscriber to data, and you can react to it over the internet. So if anyone has luck with test.mosquito.org, this port, and this particular topic, feel free to send in any message you like, and it'll continue sort of lighting up. So now I'm going to go back to the presentation. And we're going to, now that we understand how this is working, we just need to write some code, and that's it. So we know how the communication layer is working. We know how the Arduino is working with the LEDs. And now all we need to do is write some code to make the Arduino listen to stuff or subscribe to information And we also need to write the other end, which is send information to the Arduino with our phone or with like an app. So this is a simplified diagram of what's happening. The iPhone or some website is publishing to a topic of your choice over MQTT protocol to an Arduino, which is subscribed to that topic. And it's sending messages along that. So you could send strings, you could send numbers, you could send any sort of message you want. And the Arduino will just take that data and do something with it. So how can you connect an Arduino to Wi-Fi? Well, first you need an Arduino with Wi-Fi capabilities. So either you can buy an Arduino with a built-in Wi-Fi module, like this Feather M0 Wi-Fi that I've used for this smart lamp here. And this is something that Antonio recommended, and it's just been perfect. It's really nice. Or you can use a separate Wi-Fi module. So you can use your Arduino Uno or something that you get off the shelf, but you can add a Wi-Fi module like this ESP8266 module. And there are libraries built into the Arduino IDE that let you talk to it. So there are lots of ways for the Arduino to connect.
If I could jump into one thing to think about is like if you're doing a project that might be, internet connected, and you might ask like, what's the difference between using the Feather that has built-in Wi-Fi or Arduino with other things? It sort of depends on like the size that you're trying to do. Like if you want like a small box or a wearable device or a small little container, and you don't need that many pins or that much robust hardware, maybe you prefer the Feather and it costs like $30. Whereas the Arduino itself you could get for like $15. The chip is maybe like less than $5. And then it's more robust. You can do more power capabilities, add more pins. So it sort of depends on project to project.
Yeah, exactly. Yeah, thanks, Antonio. The costs I think are, I'm not sure if you have something to say about the cost of each of these. I'm thinking maybe they're comparable, but maybe it's less if you just get it inbuilt. Yeah,
they're pretty similar. I mean, like that built-in Feather, those would range between like $28 and $35, which is pretty reasonable for everything that it can do. But then the Arduino, I mean, you can get an Arduino now for real cheap. And these chips, these ESP8266 chips can run less than $5.
Yeah. Sweet. So once you have an Arduino with an internet capability, all you need to do is write some code to make it, one, connect to the internet, and two, connect to the MQTT broker of your choice. So we're going to do that now. And it's pretty straightforward. And I'll make this code available after the workshop as well. So I'm going to start off by opening up an Arduino sketch. I'm going to bring it out here. And the library that you need for this is, you need two libraries, one for the Wi-Fi and one for the MQTT. So the one for Wi-Fi is called Wi-Fi 101. You can find it in your Manage Libraries area. So it's called Wi-Fi 101. This one here, it's an official library. And then the other one is called MQTT. And it's also by Arduino, Arduino MQTT client. So what I'm going to do first is sort of just include all the imports that I need. And how I found out how to get this code working is that there are a ton of tutorials online by Arduino themselves. They've got excellent documentation. So it's very easy to get started with all of this stuff. So I'm going to put in those particular libraries. And for the Wi-Fi, all we need is these two variables, so a status and a client. And the status tells you whether or not the Wi-Fi is connected or not, and that variable gets updated. And then you also need a Wi-Fi client. Also, Arduino put this, sorry, not Arduino, Antonio put this message in the chat saying, we could do this in Tinkercad, but unfortunately they don't have Wi-Fi capabilities. So for now, I'm just going to demonstrate it on this Arduino that I have with me physically. And then you guys can come into the CID at your convenience and grab an Arduino and do this yourselves too. All this code will be available to you after the workshop. So that's the Wi-Fi stuff that we need. And this is the MQTT stuff that we need. So what broker? So kind of like earlier, test.mosquito.org, what port, what topic. You'll notice the port's a bit different, but that's just an artifact of connecting to it with an Arduino. And yeah, that's it. That's all the setup. Once we have that, we can put stuff here in Serial. This is the code that we need to connect to Wi-Fi. I'm just going to breeze through this just so I can show you how this code is put together. And what I'm doing here is I'm just connecting to Yale Wireless and I'm waiting for it to connect. If it doesn't connect, I just keep retrying until it does, and that's it. And what we can do before connecting to MQTT is just sort of verify for ourselves that we're connecting to the internet. And so I'm going to put in some helper functions to help us debug and just print out like what we're connected to. I'm just going to put them here, out of sight, out of mind. And I'm going to verify the sketch. And I'm going to put it on to the Arduino and open up the serial monitor. Great. So this is what you see if everything goes well. You connect it to Wi-Fi and it tells you what Wi-Fi network you're connected to. And this is like nice like code to have around, like nice template code. And so this will be available after the workshop. It's like just copy paste in this stuff and you can connect to Wi-Fi with an Arduino. Pretty simple. So the next thing what we're going to do is just connect to our MQTT broker, which will be done in a very similar way. So here, after we connect to Wi-Fi, because that's a prerequisite for connecting to MQTT, we're going to, in our setup, just do the MQTT stuff as well. So here, we're just going to connect to this broker, and that's specified here, test.mosquito.org. All right, so I'm going to upload that. Great, so now we're connected to the network, but now we're also connected to the MQTT broker. Cool. Another piece of copy pastable code. So we're connected to the broker, but the last piece of information that we need to tell the Arduino is which topic to subscribe to. So remember that we had a topic like CID or CID-workshop. We need to tell the Arduino to subscribe to that. What's up, Antonio?
Could you show again where you put in the broker URL?
Oh yeah, it's right at the top here in the setup, above the setup function.
That's cool. It kind of looks like when you set up like a server for a website. That's cool.
Exactly. Yeah, it's kind of corresponds to the same stuff that we saw here, with just the port changed. So now that we have that, go back. The next thing we need to do is tell the Arduino which topic to subscribe to. So I'm going to put in that final piece of setup code. All right. Oh, not in the loop, sorry. Here in the setup. Good. All right, finally. So now we're waiting for messages on this topic, CID-workshop. Cool. So that's great. Now the Arduino is waiting for messages, but now we need to actually do something with every message that's received. And that's that final piece of code where all we do is get access to whatever gets passed in to the Arduino. So all of this stuff up to now in the setup is connect me to Wi-Fi, connect me to the MQTT broker, and connect me to this particular topic. What topic? CID-workshop. And so in the loop, what we're going to do is every loop, we're just going to be monitoring for messages on that topic, and that's it. And then every time we get access to a message on that topic, we can do something with it. So I'm going to put a delay first here at the bottom so the Arduino doesn't get crazy. And all you need to do to check for an MQTT message is this guy, MQTT client.parse message. And this is this magical function that this library provides that just waits for information over MQTT, right? And if this message exists, so if the message size is non-zero, right, do something. Now, what you do is completely up to you. Drive a motor, or like turn on the lights, or like pull down a projector, or make a robot move. Anything you want can go inside of this if statement, right? But what I'm going to do is just do serial.println message received. I'm going to upload this. So I'm connected to the network. I'm connected to the broker. I'm waiting for messages on this topic, CID workshop. I'm going to go back here to my sort of interactive app. I have test.mosquito.org, my port, which is slightly different, but that's fine. And I have this topic, CID workshop, and I have some random message. I'm just going to hit publish, right? And so you can see message received, right? Because I clicked it twice. Here, I can hit publish again, message received. So now, just like how all of us were talking together over this sort of interactive app and sort of speaking to each other over this MQTT protocol, we've now had our Arduino also speaking to us over MQTT in much the same way. It's subscribed to the CID workshop topic. And so we can already start doing cool stuff with this. So if all we needed was the existence of a message to turn on our lamp, that's pretty good. So if I just change this, I have all this code here, but I have nothing to do with the NeoPixels just yet. So let me add that in. I'm going to bring in my NeoPixel code here. And I'm going to set up my NeoPixel here. And at the start and setup, I'll give them, I'll begin the pixels. I'll create this helper function to reset the pixels every time. And put it out of sight. And the last function I'll need is just a way to turn on the NeoPixels. So I can just call this default NeoPixels. And don't worry about how this stuff's implemented. It's really context dependent. So if you're driving something else like a robot, then your functions will be different. But I have a function to turn on the NeoPixels. Okay. And I have one to reset them, and that's it. So with that, now when my message is received, all I'm going to do is print message received, but also turn on my pixels, and that's it. Cool. And now I'm going to verify that the sketch works. Good. And I'm going to hit upload. And so now when I hit publish, I get message received. And because my NeoPixels are connected, if I just switch to the hover cam, the lamp's on as well. Right. So the reason why it's staying on is because I never hit reset after the pixels were turned on. So maybe all I can do is just delay for 200 milliseconds after they're first turned on and then reset them again. So it's kind of like good to have these functions around that are useful so that your main code is clean and then all the complexity is like off to the side somewhere. So now I'm going to upload again. Cool, it's reset. I'm going to go back here. Doesn't matter what the message is, just hit publish. And so it'll turn on now. So you can hit publish as many times as you want and it'll turn on every time.
Make it look so easy.
Well, yeah, it's a miracle nothing broke in that demonstration, but yeah. So I'll stop here briefly for questions before we get on to even more cool stuff. Like the cool stuff will keep coming.
I have a couple of quick questions. The first one is, what kind of information can you send the MQTT from the Arduino?
Anything you want.
Okay.
Strings, numbers. So in this code, I don't show how to send I only show how to receive information, but there are also ways to send information. So if you go to the MQTT client documentation for Arduino, I think I had it here. I'll put this in the chat in case it's useful. So this is their basic demo is just for like connecting to Wi-Fi and connecting to the broker and then waiting for a message. But they also have a way to publish a message. So all you need to do is client.publish the topic you want to publish to, and then the string. So apologies everyone, but since you're in for your making Git project, you want to send information from an Arduino to over the internet to a phone or something, right? So you can definitely do that just by like publishing whatever sensor data you have to a topic and then sending whatever info you want, like a number or a string.
Okay, cool. And then my other question is like, when you create a topic on the like overall server, nobody else can access the topic unless they know the topic keyword, right?
Yeah, so this is actually a great sort of way to go into a discussion about security. And all of these topics on this public broker are public by default. And someone could just scan all the available topics and perhaps do something malicious. So since this is meant to be like a beginner demonstration or for like most hobbyist projects, this is totally fine. Like no one's gonna hack this smart lamp and make my life miserable. Like maybe they'll mess around with it a couple of times. But if you've got something like more sort of crucial on this network, like a medical device, don't put it on a public MQTT broker. You know?
Zoom call.
Yeah. Anything which is sort of public can be Zoom bombed or MQTT bombed. Yeah, you could get around this by making your topic really like a random string of numbers, but ultimately like these things are scannable. Like just how Google can crawl the web page, can crawl the web for like public URLs, people can crawl MQTT like servers for public topics. Yeah. So one way you can get around this is by hosting your own MQTT server, right? So there are ways to set up your own. Host an MQTT server, but this is adding to the complexity and it's no longer as beginner friendly. So if you set up your own, you could be like, oh, only let people like access my server from like this particular IP address or this particular domain name or this particular locality even. So you can add in security measures there. Another thing you can do is add security. You can use a public broker, but just add security in the message that you send. So for instance, maybe you could send like a secret password every time and then a message, you know? So your device, which is on the other end, like doesn't react to it unless the password is that password, you know? Alternatively, you can, if you want to do some cryptography, you could encrypt this message. So if you had hello world, you could have some sort of secret key that is only known to both the client and like only known to the person sending the message and the person receiving the message. So you send this message, but you just send like a scramble of letters. And then people use their key on both ends to sort of decrypt the message. So kind of just using lessons from cryptography or mathematics there. So there are ways to add security. Yeah. But for hobbyist projects or just for doing quick prototyping, you're totally fine with just sending messages like bare in the wild. Yeah. If you hooked up your Tesla to this, that might be a problem. Any other questions? Cool. So now we have a way to communicate with this device through MQTT. Every time you hit publish, it lights up. Oh, you need a message. Anytime you hit publish with a message, it should light up. Sorry, not CID, but CID workshop. There we go. Good. So now let's explore the other end of the spectrum. We wrote the Arduino code, but now we want to do the other send. Like how can we send messages to Arduino with code from a phone app or from a website? Like how can we create the phone app or the website? We built the Arduino code, but now we want to do the other end. We have the communication there in the middle, MQTT. That's all fine and good. We know it works. So that's the last piece of the puzzle is how can we send information from our phone, website, or something else like Siri over the MQTT network to our smart lamp. Let's see. This stuff we already went over. Oops. So I'll go to that next slide in a minute, but for now, let me just switch to this one. And just to give you a visual, we're going to be focusing on this green part here, right, this end. And there are lots of ways to do this. in any language you choose, whether it's JavaScript, Python, like there are lots of ways to create your own program that does something similar. And I'll show you one way. I have a GitHub repo, like I have a code repository set up that gives you an example in Python and JavaScript. So I'm going to put that here in the chat. But what we're just going to do for now is just check out a simple JavaScript example. And for that, all we need to do is, whoops, can't show you that yet. All we need to do is open up any code editor of our choice. Okay, can be Notepad, can be VS Code, Atom, anything you have. So if someone doesn't have one, then maybe I can suggest an alternative. So thumbs up if you're able to open up just a random text file on your computer to write some code in. You can use TextEdit too if you want it. That's totally cool. This guy. And then whatever you save, just make sure to save it in the right format, which I'm going to show you. So what I'm going to do is use my own text editor called VS Code for this demonstration. And I'm going to create a new window. And I'll just open a random folder. So I'll create a folder maybe in my downloads or something, or you could create it on your desktop too. I'll just create one on my desktop. I'll call it like MQT demonstration. So I just created a random folder on my desktop, and you guys can do the same. I'll just open that folder. Cool. And so now I'm in this folder, and I'm going to create one file. I'm going to call it index.html. And this is just going to be a place to hold our JavaScript. That's it. Just HTML on both ends. Sorry, I have these explosive effects. I added them for a long time ago for just my own entertainment, and then I got so used to them that I don't realize that they're super distracting. They also make hilarious sound effects every time I'm coding with headphones on, so I apologize. It reduces the monotony. But what I'm just going to do is create this sample HTML file. I'm going to create a head, and I'm just going to paste this in the chat as well. Cool. And then the other thing I'm going to add in is actually, I'm just going to copy this whole thing so I don't have to bore you with writing all of this out. And I'm going to paste this in the chat too. So I pasted the contents of the HTML file that you can put into your HTML document. Cool. Okay, that's all good. And the next file I'm going to create is just mqtt.js. And it's super simple. There's not a lot there. It's just this piece of code. And I'll go into what it's doing in a second. So you've got two. Oops, give me 1 second there. Perfect. So you've got two files in the same folder, ideally. One in an HTML, but that's just random. All it's doing is referencing this. And this is where the magic's happening, the JS file, where you just have 4 lines of code. So I'm going to wait for everyone to sort of be in a point where they have index.html and mqtt.js and populated with the contents of the stuff I sent you in the chat. And just give me a thumbs up if you've been able to do that, and then we'll go into it together. All right, if it's not super clear, this is what you're going to see in your like file explorer finder. So you're going to see 2 files, index.html and mqtt.js. And in fact, I've also uploaded a zip file for anyone who needs it in the chat. So you can download that to your computer and you'll have the exact same setup as we have. Okay. So what this code is doing is it's connecting to the same broker that we've been using, the mosquito.org one with the same port. And it's just publishing to this topic, CID workshop, the same one that we've been using with some random message. It can be anything you want. And it's doing that every 5 seconds. Cool. So someone already opened it on their computer. I know that because their code is now running and this is continuously on now. So if you close out of that tab, it'll stop, whoever it is. You don't have to, but yeah. And so I can do the same here, where I can just double click this and open it up in a tab. You get a blank screen. All it's using is like your Chrome browser. The real magic is happening behind the screens, behind the scenes where the script is running, this JavaScript is running, right? If you're troubled by this blank screen, you can just go back into your code and just write my MQTT like publisher or something. So that way you won't see a blank screen every time.
You don't need to run a local server for the JavaScript to activate?
No, in this particular case, it was fine with just getting the library that we're using, the MQTT library here, this one, and this JS from here that uses that library, and that's it. Yeah, so pretty simple to like publish to MQTT with any language of your choice. So JavaScript, this is how you would do it. I have this link that I sent earlier. I think I sent it earlier. Yeah, also has a Python example. So this is how you do it in something like Python. And so you'd see the patterns are very similar. You specify the broker you want to connect to, and optionally a port. Then you specify your client ID, optional, and then you connect to that broker, and then you publish to a topic. The topic name is important, and then the message can be whatever. Right? Why is the message whatever? Because right now the Arduino doesn't care what the message is. If you recall what the Arduino code was, if you recall what the Arduino code was doing, it just checked for the existence of a message, not the contents of the message. So what we're going to do next is figure out how to check the contents of the message and use that to do something specific. So before I move on, any questions? I'm really tempted to just switch my camera to this hover cam so people can continue to look at how it's glowing, but someone's script is running. Cool. Cool, so I'll move on now. And I'll show you one way to sort of inspect the contents of the message, and then I'll show you something a little bit more advanced, which will lead us onto our big final example, which is super cool. Okay. So if you want to inspect the contents of that message from the MQTT like client, whatever it parsed, just consult the documentation. It shows you how. Or something even better, something easier, is whenever you've got any Arduino library installed, this is just good advice in general, is they usually bundle some examples. So if you go to File, Examples, and then you go out, for instance, Arduino MQTT client, they've got a really nice one called Simple Receive. So I'm going to open that one and see what it has. And so we can ignore all of that and out here. So if you notice what they're doing, whenever they receive this message, and if the message size is non-zero, they use this particular piece of code, use the stream interface to print the contents. And this is what they use to inspect what they're getting. So I'm just going to steal that and put it here. Okay. And I'm just going to upload that. Keep my monitor on. And so now I'll be able to identify whoever's continuing to run this script just based on the message that they're sending, because now it's going to be printed out to the console. So someone wrote, hello, this might just be me, TBH, but whoever else had theirs, this workshop's going great. Yeah, so whoever had that, that's what their message was. If I went ahead and changed this to new message from Sarm, then I went back to I opened this up again. So now the messages that I'm receiving will be different. New message from Sarim. Right? So at this point, you're able to not only get a message on your Arduino, but also inspect its contents. Right? So you can do anything you want with this string. Your string could be an array of like 24 numbers, each one corresponding to a pixel on the NeoPixel. And that's how you would set the color for each pixel. That's not entirely accurate. You'd have to send more like 24 times 3 because you have to send R, G, and B components for each pixel. Yeah. If you were sending messages to a motor, you could be like, oh, like how many steps that I want to move? How fast do I want the motor to move? That could be some information that you send. So anything you want, you can put in this string and you can get it into the Arduino. And the Arduino can act accordingly. So since we're running low on time now, I want to wrap it up with one like nice demo showing how all of these concepts come together. I'll go back to my slides and talk about this slide, which is you can send anything over MQTT. Anything you send can be a string. But what I've chosen to do is send a string in a particular format. Like there are many string representations possible. You could send 24 numbers in a row in one string. You could send like some like Pig Latin over and decrypt it like however you wanted over Arduino. So this is just another convention for sending stuff in a string. So I use something called JSON, which is JavaScript object notation. If you haven't heard of it, don't worry. It's just another way to represent stuff in a string. And so all that programming languages like Python, JavaScript support a way to take any sort of object, turn it into a string called JSON, and then the Arduino takes that string JSON and interprets the object. So it's kind of a way of like encapsulating all the like information that you might want into an Arduino and sort of taking it out again. So it's just another way to, it's just a notation that we use to represent stuff. But it's a powerful one. So for this last demo, what I'm going to show is we have our code here, and I'm just going to replace it with some other code that helps me control each of the NeoPixels specifically. So this piece of code is just taking in JSON that it receives, that same like formatted string that I sent, and deserializing it, basically interpreting it, and then getting the red, green, and blue components. And I'll sort of show where those come from, right, on the client side of things. And then with that, it's just going to light up all of these pixels with the red, green, and blue components. So it just took all the information that we sent over MQTT, it extracted out all that information, and it's going to address each one of those LEDs separately. Right? So it's not very different from what we had before, just like a little bit more complexity to do something more specific. Because people's scripts are still running, I'm going to change the topic to maybe something else like CID, like sample or something. And so then I can show this demo, but without this happening. I'm just going to upload this. It's just perfect. Great, so we're connected to the network, we're connected to the broker, we're subscribed to the topic, everything's same as before. It's waiting for messages, but the only thing that's different now is it's going to interpret whatever string is sent over as this like special notation. It's going to decrypt that notation and extract the red, green, and blue components, and that's what's going to light up this guy. And I hope that we can make this interactive. So what I'm going to show is this sample application that I built to show that really your client can be at any sort of level of complexity that you want. Your Arduino is just doing the same thing as it was always doing, waiting and listening for messages. And you can send along those messages and it just works. So I'm going to open up this. I'm not going to share the URL just yet, so just so I can give a demonstration. But this was a sample app that I put together that lets you pick a color for each one of the pixels. So like red. And this is where you can see what the like JavaScript object notation, the JSON string is formatted as. So it's got a red component with 24 values in RGB, like green component, blue component. So RGB, the colors range from 0 to 225. As for why that is, that might be another lecture, but this is just how you can represent colors. And so I've represented each of the 3 components, and I'm going to pass this information on to this guy. I'm going to change the topic here so it goes back to CID sample. I'm just going to hit submit.
Hover cam.
And so let me hover cam. And so right now everything's red. I can submit that. I can also like drag and select some so that half of them are like green and blue, half of them are red. I can just like continue to experiment, make it a whole like medley of colors. Maybe some of them can be orange. Awesome. So now it's time for you guys to try it out. So I'm going to put the link in the chat and make sure to change the topic to CID-sample. And feel free to try it out. Sweet, we got our first customer. So just as a reminder, to set the topic to CID-sample, and you can drag select whatever pixels you want to change and set their color. And all along the way, you can sort of see what's coming in on the serial monitor too. So in the serial monitor, this sort of like information, this JavaScript notation, like information is also being printed out. Not exactly, because what we're printing out is more so just the red components. We're not printing out that whole object that we have here. We're just printing out the red component just to verify that it came through. Cool. So this kind of like project shows well the extent of what you can do with the Internet of Things. You have something that talks to the internet, you create some relatively simple API that takes information from the internet and does something with it. And then on the other end, you can make your app as complicated as you want. You could make this into a nice phone app if you wanted. The underlying principle would be the same. It's sending messages over MQTT. Right? And MQTT is not the only thing you could send messages over. Like I said earlier, there's also WebSockets, HTTP. So the possibilities are really endless here. And the last thing, which was how to create something with Siri, that's also pretty simple too. Siri has something called Siri shortcuts, where you can just send through some sort of special app on the App Store for MQTT, just create a shortcut that sends in some information to the Arduino. So notice that nothing changed on this side of the diagram. Like that stuff is still the same. The communication over MQTT and the way the Arduino subscribes to that information. Everything, all the complexity just got added on the left side, which was this green stuff. And so you could make this as simple or as complex as you wanted. And with that, that's the end of the workshop. Thanks, everyone. And yeah, I'll stick around for any questions.
This is great, Tom.
Thank you.
All right, thank you very much. See you guys.
Thank
Good
you.
dinner.
Thanks for coming.
Thanks, Sarum. This was so cool.
Thanks, Anusha.
Kind of unrelated question. Do you know why they call it a Wi-Fi shield?
Why they call it a shield?
Yeah.
Is that,
I'm not sure.
Is this a joke or is it like it sounds like a setup for a joke?
No, I'm actually wondering.
Okay.
I think it's funny, so I sound like that, but it is.
Sorry,
it's
sorry.
a question.
They call any breakout boards that you put onto like insert into the existing pins of an Arduino a shield, because it usually just like hides the existing face of the Arduino as if it was like this hard surface shield. So they have like LED shields, they have like Wi-Fi shields, all sorts of stuff like that.
Okay.
It's just like a lingo of the hardware.
So, Aaron, what did you do to modify your Visual Studio Code like that?
Oh, I can show you. It's I forget what the extension is. I think it's just called dude, I can't really. I'm trying to look through all my extensions, but I have quite a few. I think it's called I'm sorry, can I look it up and send it to you?
Yeah, sure.
Okay.
Thanks for
Sorry
saying
about
that to
that.
me.
Yeah. See
Huh?
you around. Thank you.
Yeah.
All right, see ya. Bye-bye.
Hey, I stopped recording.
Yeah.